Now continuing with our 7.3, we're going to look at poll results. So when you see poll results in newspapers, magazines, on the news, what they are reporting basically is a confidence interval that you're looking at. So when a poll states the results of a survey, the proportion reported to respond in a designed manner is p hat, the sample estimate of the population proportion. The margin of error is the maximal error E of a 95% confidence interval for P, and a 95% confidence interval for the population proportion P is your poll report P hat minus your margin of error, and your poll report P hat plus your margin of error. So reading through an article, for example, like example 7, in a political article, the phrase is chances are 19 to 20 that if, what's the confidence level that corresponds to the phrase? So if we're talking about chances of 19 to 20, that's your percent that you're going to have for your confidence interval. So if we take 19 divided by 20, we are going to see then we get 0.95. So really, instead of them saying a 95% confidence interval, they're saying chances are 19 to 20. The complete article indicates that everyone in the sample was asked the question, which part, the Democratic or the Republican Party, do you think would do a better job handling education? Possible responses were Democrats, neither, both, or Republicans. The poll reported that 32% of the respondents said Democrats. Does 32% represent the sample statistic p hat or the population parameter p for the proportion of adults responding Democrat? Now think about this. They're not going to go through and poll every single person in the U.S. So when they poll a sample. So that 32% represents the sample, not the population. So it's going to be our sample p hat. Then for C, the last paragraph of the article states, if all adults with telephones in the U.S. had been surveyed, the findings would differ from these poll results by no more than 2.6 percentage points in either direction. Use this information together with parts A and B to find a 95% confidence interval for the proportion P of the specified population who responded Democrats to the question. So going through this, when they are saying no more in either direction, that's your E. So they're saying E is going to be 2.6%. Now, usually we do E and our P hats in terms of decimals, not percents. But when we're looking at these polls, usually they're not going to tell you that it is a 0.026 result of points either way, or it's a 0.32 that represents your sample. Usually in these problems, they're going to explain things in percents. So when we write out our interval, I'm going to actually write them in percents, not write them as decimals, just because everything else is already in percents. But if you want to write things in decimal form, you can do that instead. So your P hat is those that responded for that 32%. We're doing the same thing we were just doing. P hat minus E, P hat plus E. So we are going to have 32 minus 2.6, 32 plus 2.6. So we have 29.4%, and we've got 34.6%. So they are saying then in this problem, we are 95% confident that at the time of the poll, between 29.4% and 34.6% of the population thought Democrats would do better at handling education. So again, between 29.4% and 34.6% of that population thought Democrats would do better at handling the education. So again, when you go through these, it's the exact same stuff. It's just we put it into wording and numbers that people might understand better than saying 0.294 and 0.346. Most people understand percents more than they're going to understand those decimals of proportions. Now, in 7.1, we found what n was equal to. You're going to do the same thing here in 7.3. So you can figure out what your sample size should be, but we have two formulas to follow. One is if you have a preliminary estimate for P. One is if you don't. So if they tell you what P is, or they give you numbers to make a proportion for P, you use the first one. If they don't give you any numbers at all, then we use the second one. Now, just like before, if your N is like 10.3 and you're talking about people, we can't have 10.3 people. So we'd round up to 11 then for our sample. So going through these, you're having a sample. So you're having an actual amount of something or a number of something. So we're not going to have a 0.0 something something. We're not going to have a decimal to it. We are going to have whole numbers that are bigger than 1 going through these. Because again, you're looking at your sample, your N. That's what we're solving for. So for example 8, a company is in the business of selling wholesale popcorn to grocery stores. The company buys directly from farmers. A buyer for the company is examining a large amount of corn from a certain farmer. Before the purchase is made, the buyer wants to estimate P, the probability that a kernel will pop. Suppose a random sample of N kernels is taken and R of those kernels pop. The buyer wants to be 95% sure that the point estimate P hat equals R over N for P will be in error either way by less than 0.01. If no preliminary study is made to estimate P, how large a sample should the buyer use? So again, going through. For A, there is no preliminary study, none at all. So that means we have to use then our N is equal to 1/4, and then we're doing ZC over E squared. Now they tell us we're 95%. Remember, we are looking at the Z chart, the little one, for the 95%. So you want to find your ZC for 95%, and that's going to go in for ZC. So look at your little table. We should have 1.96. RE then should be 0.01 because they have an error either way of 0.01. So we do 1/4, 1.96 over 0.01 squared. Again, make sure you're typing that in correctly into your calculator. You should get 9,604. Because that rounds nicely to a whole number already, we can leave it. And we're looking at kernels. Now for part B, they give you a P. So now we're using the other formula. So P times 1 minus P, and then we tack on at the end the ZC over E squared. So now plugging things in where they go. They tell us that our P is 0.96. So we have 1 minus 0.96. Now the nice thing is, for this problem, you're using the same ZC and E from part A. So we've got 1.96 over 0.01 squared. So the only thing different is they now tell us what our P is. So I can type all of that into my calculator, and I get 1475.17. Again, we have to round up. So I have 1,476 kernels. So if we actually have that preliminary estimate, we can have a smaller number in our sample. Without having that preliminary estimate, we have to have a bigger amount for us to get what we want. We can have a smaller amount here if we know what's in, what the preliminary estimate was for our original study or a different study that was similar to it. So again, going through these, the n should have numbers bigger than 1. If you're solving for probabilities, you should have numbers smaller than 1. So make sure you're paying attention to those as you go through it. Again, WebAssign will tell you what they want you to round to also.